Our second speaker this evening, and that is Lloyd Smith. In case you're wondering what he's going to be speaking about this evening, you don't have to wait much longer. Gambling dates back thousands of years, probably tens of thousands of years, into humanity's past, making it one of our oldest activities. In fact, the modern mathematical study of probability, which dates back to the 1600s, was invented to make gambling understandable. In Project 2, Resources for Informing, from the Advanced Communication Theories Manual, Speaking to Inform, Lloyd Smith will discuss some practical rules of probability that might profit us all. Lloyd Smith and wanna bet?
Probability is an interesting theory. It's one of the very few areas of mathematics where theoretical principles can actually affect our daily lives. Most of us don't get much out of topography or anything similar, but probability we can. Probability is easy to understand. Madam Toastmaster, fellow Toastmasters, and yes, it's based on a very simple principle, calculating odds. This is a genuine Canadian flipping coin, a $1 flipping coin. It has a queen on one side and a bird on the other. If I want to know the odds that I can flip the coin and have queen come up, I simply count the number of possible ways queen can come up, which would be 1, has to be facing up. Then I count the number of possible things that can happen when I flip the coin, which would be 2. It'll come up one way or the other. I divide 1 by 2, and the odds that I flip a queen is 1/2, or 50%, which you already knew if you've been alive very often. Now, the thing about probability is it's easy to understand. I just explained it. But it's also very easy to get confused. And I'd like to offer 3 basic principles that can lessen that confusion for you. The first one is that there's more than one way to think about probability. How many of you heard this morning on the weather forecast that there's a 40% chance that we're going to get snow showers on Thursday? Nobody ever heard, right? However, when the National Weather Service says that, they don't mean that there is a 4 in 10 chance that it will snow on Thursday. They mean it a different way. They're expressing the long-term percentage chance that that will happen. What really occurred was that they had their supercomputers, and supercomputers, by the way, were invented in part to calculate weather. But they had their supercomputers look through all of the data. They found all of the days that it ever happened when we had the same temperature, humidity, wind conditions, and so on that we're likely to see Thursday. And they discovered that on 40% of those days, it snowed. So when they say there's a 40% chance of snow, it's not the same thing as 4 in 10. That actually leads us to rule number 2, which is that you have to understand the long-term versus short-term probability. I don't know how many of you remember back to when the Washington State Lotto was invented, but do you remember the first advertising slogan? Some lucky dog has got to win it. Now, in the long term, that's exactly true. If you do enough lotto drawings, sooner or later, every possible combination of numbers will be drawn, and that lucky dog will win. However, in the short term, the odds of winning an individual lotto drawing back then was 1 in 7 million. It was a 5-ball game. In other words, it would have taken 135,000 years of lotto drawings in order to have every possible combination of numbers drawn. And that means that lucky dog would be over 1 million years old in 5 years. It would happen. But you need to think to yourself, what's a reasonable time frame before I decide that the odds are in my favor? You may be thinking to yourself, 1 in 7 million sounds pretty good compared to the Powerball lotto, the modern Powerball lotto, where the odds of winning are 1 in 135 million. That's because the original Washington State Lotto was a 5-ball game, and the Powerball game is a 6-ball game, and that 6th ball has to be a particular number. Now that leads us to rule number 3, and that is that the odds of a chain of events happening are calculated by multiplying the probabilities that each one of them will happen. Think about our flipping coin again. What are the odds that I could flip this coin 5 times in a row and have it come up heads each time? Now, we already know that the odds of doing it once, it did come up heads, by the way. We already know that the odds of doing it once are 1 in 2. The odds of it happening 5 times in a row would be 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which of course is 1/32, or roughly 3 times in 100, 3%. Now, it's true that each time I flip the coin, it's less likely that the next flip will be a head. But here's something you've got to think about. This coin doesn't have a memory. It's just a hunk of metal. Okay, so each time I flip the coin, the odds of that particular flip being a head are exactly the same. Even if I flipped it 1,000 times in a row, and the first 999 of them were heads, the odds that the next flip will be a head is exactly 1 out of 2, just as it was for the first one. What that means is that there's no such thing as being on a roll, or that there's an event that's due to happen. I was in a gambling casino in Las Vegas once when a guy got up to go to the bathroom from his slot machine, came back, and another person had sat down at the machine. He became so enraged he started beating on the guy. That's because he believed that the machine was due to win, and he needed to get his machine back so that he could do that. No, it wasn't. The first push and the 1,000th push were equally likely to win. Now, the interesting thing about gambling and probability is that no matter how much people know about it or study it, they're blinded to the idea of the reality of probability because it looks like you can beat the odds. You know, and we've all heard of people who have beaten the odds in a significant way. So, assuming that you forget everything else I said here, I want you to remember this 4th bonus rule. The next time you're standing in front of a gambling establishment, whether it's Caesar's Palace in Las Vegas or Kegler's Card Room over in East Wenatchee, ask yourself this simple question. How do they pay to run this place if all of the gamblers are? Yeah.